Okay, so in the last unit, I have explained about the microwave devices. Okay, it is what actually the microwave means and what are the microwave devices. An example as the if you take the TWT2 or if you take the magnetron or if you take the klystrons. Okay, all those are called as of the microwave devices. Okay, all that has been explained in the previous class. Okay, and in this class we are going to see the it is unit 2. It's radar principles and applications. Okay, and in this class I am going to explain the introduction to radar. Okay, and I am going to explain this what is the definition of the radar and what is the basic principle of the radar system and what is the block diagram of the radar and it is what are the applications of the radar. Okay, all that we are going to see in this class here. And in this case, if you take the definition of the radar, okay, so what the radar is the acronym, it is for the radio detection and ranging. So it is what the first two alphabets RA is acting as the radio, RAADIO. Okay, and what is D indicating? It is detection. Okay, the actual meaning of the detection is to identification or identifying, and A indicating the and R indicating the range. Okay, what the range means, it can able to measure the distance. Okay, either in terms of the kilometers or in terms of the nauticals. Okay, this is itself is the expansion of the radar. It is a radio detection and ranging. So if you take a radar system is usually operates in the ultra high frequency or the microwave part of the radio frequency and is used to detect this position and or the movements of the objects. Already you know about the microwaves. It is going to be get operated from, it is 300 megahertz to up to 300 gigahertz. Okay, if you take the part of the microwaves, it is internally classified into of the main three bands. Yes, no. It is UHF, SHF, and it is what VHF. So if you take the ultra high frequency range, and it is nothing but the part of the microwave, it's nothing but the radio frequency. Okay, if the signal is to be get operated under the ultra high frequency, and it is used to detect the position of the target and also its movement, it is itself is called as the radar. Understood the definition? Okay, if you take the definition of the radar, it is going to be get operated under the ultra high frequency. Ultra high frequency, it's nothing but it's the part of the microwave. Okay, it is going to be get operated under the radio frequency spectrum, and it is used to detect the actual position and also the actual movement of the object. It is itself is called as the radar. Okay, if you take the basic principle of the radar here. Okay, suppose consider it is the radar transmitter. Okay, and it is the reflecting target. Okay, so in this case, what happens here is it is what this radar, it is going to send the electromagnetic radiations into the space here, and it is to be get okay reflected, it is by the target here, and it is going to get the what echo signal, again it is to be get received by the radar here, and it is based on the received signal, it can able to it can able to detect the actual position, okay, range and also the direction. Okay, so that you can able to see a transmitter generates an electromagnetic signal, okay, that is radiated by an antenna into the space, so that you can able to see this is the transmitter and it is to be connected with the okay antenna, and it is going to radiate the what electromagnetic signal. It is to be radiated into the space here, and a portion of the transmitted electromagnetic energy is to be reflected back, it is towards the radar. So it is whatever the signal so has been radiated into the space, out of which only it is some portion is to be get hitted, it is for the target, and it is going to come back again to the radar. Okay, and it is based on the received target echo signal. Okay, what this receiver, it can able to make the decision of the position, it is what actually its position, it can able to identify its position in the form of the angle, and it can able to identify the range, it is what is its distance, it is from the earth. Okay, it can able to measure in terms of the kilometers, and it can also able to measure the direction, either is it coming towards the earth or is it going away from the earth, all it can be able to measure, it is by the radar. This is itself is the basic principle of the radar system. Understood? It's very simple. It is what this a transmitter, it is going to send the electromagnetic signal into the space, and it is to be get what hitted by the, it is a target, and afterwards it is going to reflect one echo signal, and it is to be get received again by the radar. It is based on the received signal, it can able to measure the position of the target, and it can able to measure the range at which it is available from the earth, and it is also going to measure the direction, either it is traveling towards the earth or is it going away from the earth, it is going to be get measured by this radar. This is itself is the basic principle of the radar system. Understood? Okay, and the next one, if you take the block diagram of the radar system, if you take the block diagram of the radar system, it is mainly consisting of the transmitter, okay, duplexer, okay, receiver, okay, radar antenna, and the indicator. So this all is to be represented in terms of the block. Observe here, this is the transmitter, this is the duplexer, this is the receiver, and it is the radar antenna, okay, indicated with the green color. And you can able to see this is the display system, it is acting as the indicator here. If you take the cathode ray tube, or if you take the LCD display, etc, etc, all those are acting as an indicator here. Okay, and if you take its working principle is very easy here. It is what this transmitter, it is going to radiate the high frequency, okay, radio frequency, okay, signal, and it is to be passed for the duplexer here. And in this, what this duplexer, it is acting as the switch here, and it is going to give the antenna connection either for the transmitter or for the receiver, only one. And if the signal is to be get transmitted, what this duplexer it will do is, it is going to give the connection for the transmitter. And if the signal is to be get received, it is from the antenna, means what this duplexer it will do, it is going to give the connection for the receiver here. In this case, it is acting as of the dipole switch. Okay, so what this transmitter it will do, it is going to radiate the what high power, it is a radio frequency signal, and it is to be passed into the duplexer. And what this duplexer it will do, it is going to receive the signal from the transmitter, and it is to be passed to the radar antenna. And in this case, what this radar antenna it will do, it is going to convert the RF signal, it is a radio frequency signal, into the electromagnetic signal. And what this electromagnetic signal, it is to be radiated into the air or into the space, and afterwards it will reach the target here. And after reaching the target, it is going to reflect back, it is some part of the signal, and it is called as the echo signal. And again it is to be get received by the same antenna radar, and it is whatever the signal received, it is to be passed into the duplexer. And in this case, what the duplexer it will do, it is going to terminate the connection between the transmitter, and it will establish the, it is connection for the receiver here. And it is whatever the signal so has been received by the radar antenna, it is to be passed into the receiver. And in this case, what the receiver it will do, it is going to demodulate the signal, and afterwards it is to be passed into the display, at which the signal is to be get displayed here. So if you take the transmitter, so the flow will be in this way. It is from the transmitter enter into the duplexer, and after that enter into the antenna, and it is going to convert as electromagnetic wave, and it is going to move for the aim. So from the transmitter it will go to the duplexer, and from the radar antenna it will move to the target aim. And if you take the receiver, exactly opposite. So from the aim, so it is going to start from the aim, it will it is going to transmit as an echo signal, and it is going to received by the receiver antenna. It is to be passed into the duplexer, and afterwards it will enter into the receiver, and from the receiver it will be displayed on the display, which is act as an indicator here. Understood? This is the block diagram of the basic radar system. So if you take any of the radar, it should have all these components are the basic. Okay, and it is itself has been indicated in terms of the sentences here. Okay, so a radar is going to transmit what this radar transmitter is going to produce the short duration high power RF pulses to the energy. It can be transmitted into the space by the antenna. And what this duplexer it will do, so it is going to alternately switches the antenna between the transmitter and the receiver. Okay, so that only the one antenna need to be used. Either it can be act as the transmitting antenna, or it can act as the receiving antenna. Only one antenna has to be used. And what this switching is necessary, because the high power pulses of the transmitter would destroy the receiver if the energy were allowed to enter the receiver. So that means that if it's not having the switching, means it is whatever the signal has been transmitted, it may enter into the receiver here. In order to block that one, it can able to give the connection either for the transmitter or for the receiver, only one. Okay, and after that, what this receiver, it is going to amplify and it is going to demodulate the received RF signal. And what this radar antenna, it can able to transfer the transmitter energy, okay, two signals into the space with the required distribution and the efficiency. The antenna, its duty is to only to transmit the signal and to receive the signal, okay, with the efficiency. And what this indicator it will do, the indicator is going to okay present the observer a continuous easily understandable, okay, the graphic picture of the relative position of the radar, okay, target. It is what is its direction, what is its position, what is its range, all is to be get displayed by this indicator here. Okay, this is about the basic block diagram of the radar system. Understood? And after that, if you take the applications of the radar, it is being used in the number of the applications here. What these radar systems are, it is widely used in the air traffic control, okay, and used in the aircraft navigation, and used in the marine, okay, navigation, in the sea, in the ocean, okay. And if you take an example for the aviation, means the aircraft are equipped with the radar devices, okay, that warn of the aircraft or other obstacles in or approaching their path. It is a display, it is weather information, and also it can able to give the accurate altitude, okay, reading. So what that radar devices used to be fixed in the aeroplanes, okay, and it can able to give the readings of the weather, and it can able to give the approaching path, and it can also able to give its altitude. It is at what distance is it is above from the ground. Okay, all of that parameters used to be get displayed with the radar in the aircraft here, okay, in the aeroplane. And what these marine radars inside the ocean or inside the sea, okay, are used to measure the bearing and what the distance of the ships in order to prevent the collision with the other ships, and to navigate and to fix their position at the sea. It is when within the range of the shore or other fixed references such as islands, bayous, or the light ships. It can able to identify the islands. It can able to identify either any of the nearby ship is approaching towards it, etc., etc., all that it can able to give the information for, it is from the marine radars. It is to the ships. Okay, and in the port or in the harbor or in the vessel traffic service radar are used to monitor and to regulate the ship movements in the busy waters. Okay, if the number of ships are approaching at the same place means, so that it can able to measure or it can able to give the actual distance between the ships. Okay, all that it can be able to be measured here. Okay, in the harbor. And if you take the few more applications, so if you take the high power radar, it using the large dish antenna, so has been used to measure the distances to the moon, other planet, asteroids and artificial satellites also. It's not only applicable for the aircraft and the marine, it can also able to measure the distance, it is from the earth to the moon and from the other planets to the earth. Also it can able to give the okay actual range. And it is from the unnamed space probes what this radar has been used to map the Venus, whose surface is observed at the visible wavelength by the thick layer of the clouds. Okay, so it's already the studies say, okay, says that it is from this it can able to measure the distances from the Venus planet, its surface and all that. And what this radar has been employed by the it is NASA, it is US National Aeronautic and the Space Administration in order to make the highly detailed topological maps to of the Earth's surface as well, so that you can able to see the Google Earth. Okay, what that it is to be measured from the, it is a radar only. Okay, and if you take the normal functions in general, if you take the applications of the radar means, it is able to measure the range, it is from the pulse delay, and it is able to measure the velocity, it is from the Doppler frequency shift, and it is able to measure the angular direction, it is from the antenna pointing. All these are the major three functions of the radar. Understood? It is used to measure the range, it is used to measure the velocity, it is used to measure the angular directions. All these three are the important functions of the radar here. Okay, so in this class I have explained it is what actually the definition of the radar. It's the radio detection and ranging, and it is to be get operated with the ultra high frequency. And what the basic principle of the radar, it is going to send one signal, it is going to be reflected back, and it is based on that one it can able to measure the position, okay, range and the direction. And what the block diagram, it's mainly consisting of the transmitter, duplexer, okay, receiver, and the antenna, radar and the indicator. And if you take its application, it's mainly used in the aircraft, used in the marine, and used to measure the distances from the moon or other planets or artificial satellites, and used to measure the surface of the other planets, and etc etc. If you take the normal, it is used to measure the range, it is from the pulse it is okay delay, used to measure the velocity, it is from the Doppler frequency shift, and used to measure the angular direction. Okay, important functions of the radar basis. Okay, if you take the sample descriptive questions on this one means, he may ask you to okay define the radar, explain the basic principle of the radar here, or he may ask you to explain the block diagram of the radar system, or he may ask you to okay he may ask you to list the applications of the radar here. All these three questions are the basic questions. It is to be asked according to the syllabus what I covered. Okay, so this is all about the introduction to the radar, and in the next class we are going to see about the parameters of the radar here. Okay, okay, thank you.